So here we're going to work kind of backwards, whereas sometimes you're given a formula for a piecewise defined function and you have to graph it. Here we're going to look at how to take a graph of a piecewise defined function and find its formula. Before we get into it, I want to discuss a couple different things. In this video we're going to look at piecewise defined functions made up of lines in particular. So we have to talk about lines. We can have slanted lines. A slanted line, the equation looks like y equals mx plus b, where m is the slope, or rise divided by run, and b is the y coordinate of the y-intercept, is the y coordinate of the y-intercept. Okay. The other case, if we're dealing with functions, is a horizontal line. And those are very simple. They're just y equals some number, basically wherever the line crosses the y-axis. It's a constant function. Okay, so we'll use these concepts in the example we're going to look at. So here we have a piecewise graph of a function called f, and we're supposed to find an equation or a formula for this particular function. And there is more than one answer for this. But here's what we're going to do. This first line, basically there's three pieces. So we know that the function is going to look like f of x equals, and then we're going to have three output formulas. Okay, so three output formulas. So you write the output formula first, and then you put a comma, and then you say if or for, either way is fine, and you describe which x values you use for that output formula. So what we're going to do here is we're going to have three pieces. The yellow piece is going to be the first one. The green piece will be the second one, let's say. And then the blue piece will be the third one. Okay. Now since these are lines, it makes it pretty simple. We've got the yellow piece is a slanted line, which means it's going to be y equals mx plus b. So we need to know the slope. Well, you can find the slope pretty easily here. You can see that, for example, if I start at this point and I want to go to this point, that would be rise 1, run 1. Rise equals 1, run equals 1. So your slope will be rise divided by run, 1 divided by 1, so that'd be 1x, plus b. B is where the graph crosses the y-axis, or where it would cross the y-axis. If this graph continued following the same slope, it would cross the y-axis at y equals 0. So b is 0. So that means that the function output is given by 1x plus 0, or just y equals x. Now when you go to write your piecewise defined function, you don't have to write y equals. You don't do that because you've already got the y equals right here. F of x is y, so it already says y equals. So all we do here is put the output formula, which is just x. Now when do we use that output? Which x values? You list the x conditions here. You use this output if x is to the left of this x value here, which is -1. So if x is less than or equal to -1, the reason we say or equal to is because this boundary point is a closed circle. Okay, so we have our yellow piece done. Now let's look at the green piece. The green piece is pretty simple. It's a horizontal line, and it's just y equals 1. It crosses the y-axis at 1. So that means when I go to my piecewise defined function for the green piece, I have y equals 1. Remember, these are my output formulas. y equals 1. And then what about the x values for the green section? Well, the green section happens between -1 and 2. At -1 you have an open boundary point, so that means x is greater than or equal to, sorry, not or equals to, just x is greater than -1 because that boundary point is not included. In the 2, x is less than or equal to the 2 because it's a closed boundary point. Now really, when you look at this, only one of the pieces, only one piece can include this boundary point. That's because a function can only have one output per input, so this is kind of a caveat to that. So now let's look at the blue piece. So we need y equals mx plus b again, so I need my slope. So let's see, if I start up here at this point, my rise is -1, 2, 3, and my run is 2. So my slope is -3/2, so that's my m, times x, plus my b value. My b value is what I'd have if my slope continued and hit the y-axis. So that means rise 3, run -2, it would hit up here at 4. So -3/2 x plus 4 is the output formula for the blue portion, and we use that for x values bigger than 2. We can't say equals 2 because we chose that for the previous region, so we'll say if x is greater than 2. And so this is a formula or equation of this piecewise defined function. Now understand that either of these could be switched. This green portion could be when x is less than 2, but then the blue portion would have to be when x is greater than or equal to 2. One of them would have to include that boundary point at 2. And that's how you find the equation for a piecewise defined function made up of lines.